Okay, so let's get started. We're going to be taking a look at our knock control logic found within our Gen 3 engine control modules. We have to understand this in order to understand how to calibrate and tune our spark timing. So this is going to be understanding what's going on within the logic system and being able to take a look at a data log and spot what's going on with our knock control, and then potentially what we might want to edit and change into something like our borderline spark timing tables to get the best possible spark advance and the safest spark advance out of our engine so that we can extract the best horsepower and torque. We know that there's a direct correlation between spark timing and cylinder pressure, and we always want to try to get up to maximum brake torque, but we don't necessarily, not necessarily reach that depending on the octane and other factors or conditions that we have going on. The knock sensor is going to essentially bridge the gap between what we call out as a starting point for our spark timing and borderline, and then getting up to our maximum brake torque timing values. We'll find that it's going to allow us to vary the amount of spark advance we add into our engine or allow the engine to run at to keep it safe and to extract the best power out of our engine for the given octane that we have. And again, the other operating conditions or factors such as ambient air temperature, engine coolant temperatures, things like that. So let's jump in and let's take a look at a stock equivalent file. We're going to look at a couple sections within our calibration file for working within the knock control routine. We're also going to take a look at a data log here I'm providing in this particular tutorial for looking at knock control and how it actually functions and works. Again, pretty simple system, but we do need to see the strategy and how everything's implemented here. Okay, so what we're going to do is open up a stock equivalent file. We'll go here to File, we'll go to Open, and we're going to move here to the desktop, and we're going to go up here to HPT Gen 3 course folder. We're going to move into our sample calibration file subfolder, and then finally we'll open up a stock equivalent file here. So 2019 Mustang GT manual stock. We've been using that throughout the training course. We'll open that up here real quick. Now I'm going to move into Engine tab, and then I'm going to go here to General and move over here to Spark. Now we have three tabs technically we're going to be looking at here, talking about our spark control routine and our knock control. Specifically, we're going to be looking under our Advanced tab here at our cylinder trim tables. These are key because we are going to be operating our knock control within a per cylinder basis. So it's looking at the actual knock sensor right after we fire off the spark plug, and it's going to determine if it needs to advance or retard the spark timing from the borderline values to get as close as we can get to our maximum brake torque. Maximum brake torque is the ideal spark timing that we deliver to the engine to get up to the safe and maximum cylinder pressure. Anything above maximum brake torque is not considered to be useful to run because we call out more spark advance and it doesn't equate to higher cylinder pressure and therefore higher torque and horsepower output. So the maximum brake torque is treated as our ceiling, the borderline is treated as our starting point. We can add or subtract at the borderline with our knock control routine. We use something like our individual cylinder trims here to balance out any cylinders that may be more knock prone than others. So as the airflow is coming into the engine, it doesn't always distribute evenly between all the cylinders, and we'll find that typically one or more cylinders is more knock prone than the others, and we can spot that trend and make those adjustments. Ford's actually done that for us already in these tables, as we'll look at a little bit later in the training module here. If we move over to our retard tab, we're going to find this is going to house the knock logic of how things work. We have some control over some things here with the knock control routine and the programming. And then finally, we have our knock sensor tab over here. This is where we have our knock threshold tables. These are used to distinguish between engine noise and what's real knock. So anything that's going above the threshold in a particular cylinder, that's going to tell the engine control module it needs to take action. And it's going to, in that case, pull spark timing. And then it can detune that cylinder and get that cylinder under control so that there's no knock showing on the knock sensor. Likewise, if we're below the knock threshold, it tells the knock control routine to increment up the spark advance in that cylinder because there's no knock event, and we try to get closer to the maximum brake torque. This is a dynamically moving system, and we'll find again it's on a per cylinder basis. Let's jump in here real quick. We're going to go back to our retard tab and talk about a few things. So if we look here under our retard tab, this is where the knock control system starts. We have our knock mode. There's a per cylinder and global. For all the Gen 3 engine control modules, at least in the Mustangs that I've ever looked at, it's going to be a per cylinder option. The per cylinder unlocks a per cylinder spark advance or retard control. So what's going to happen is we start off at the borderline. We obviously have our VCT schedule. We call out our map point as we're operating. It's going to be associated to one or more map points. If it's calling out multiple map points, it has a weighting average or percentage between different map points. It'll then absorb whatever the spark timing is across a couple tables or a single table. And if it's doing a couple tables to do an averaging effect, it's going to come up with a spark timing amount it's going to start at. Then in this per cylinder option, every cylinder is monitored for knock. We are able to either add or subtract timing from our borderline mapped point spark timing that we call out. And it's going to allow to add timing up to the point where we get to the ceiling of our spark timing routine here, which is typically maximum brake torque. We either reach maximum brake torque or we reach a situation like our pre-ignition limit or our cylinder pressure limit. So these act as a ceiling. The engine control module will take the lowest spark timing of all the cylinders here, or the ceilings, I should say. So whether it's pre-ignition, cylinder pressure, or whatever map point we're pulling from, whatever that spark timing is, the lowest value will be the highest amount of spark advance we can run. We start at borderline. The knock sensors are add or subtract to that. We add to the borderline if there's no knock, up to the point where we're reaching one of our other limit tables. Again, these are...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.